Hello everyone, and welcome to my research presentation for the Cloud Computing and Internet of Things module. My name is Kushan Kavind Saranasinghe Edrisuriya. My student ID is 250403554, and this presentation accompanies my assignment 1 research report. Today I will be presenting a critical review of an important paper on the integration of blockchain and the cloud of things. The paper I have chosen is by Nijan, Pathirana, Ding and Seneviratna, published in IEEE Communications Survey and Tutorials in 2020. By the end of this presentation, we will understand the BCOT paradigm and its architecture, its real-world application, and critical legal, social, ethical, and professional challenges it raises. Here is the agenda for the presentation. I will begin with the introduction and background, and explaining blockchain and cloud of things are important individually together. I will then walk through the aims and objective of the report, followed by literary review covering the key papers in the research area. And after that, I will discuss specific contributions as Nijan and the companies including this blockchain architecture. I will be cover the research methodology, followed by critical analysis comparing the paper against the broader literature. The bulk of the middle section addresses LSEP, legal, social, ethical, and professional issues across three dedicated slides. Finally, I will be present the discussion of findings, conclusion, and references. The total presentation is near 10 minutes. So let me begin with the background. Blockchain technology has rapidly evolved from the public ledger underpinning Bitcoin in 2008 into general purposes decentralized computing paradigm that is reshaping financial and industrial services. At the same time, the convergence of the Internet of Things, or IoT, and cloud computing has produced that what researchers call the cloud of things, or COT. In the model, resource constrained IoT devices, sensors, whereas industrial delegate their storage and computation and elastic cloud infrastructure. While the COT delivers scalability and on-demand processing, it relies on centralized architecture, introduced three critical problems: single point of failure, latency, and the unresolved data privacy concerns. This creates an opportunity for blockchain to complement the COT, and this is precisely the gap of that the BOT paradigm addresses. The paper I am reviewing was first comprehensive survey to the blockchain, cloud computing, and IoT as a single integrated BCOT stack. In slide 4, the primary aim of my report is to provide a critical evidence based on review of the BOC paradigm as presented by this paper, and the situation within cloud of things and research. I pursued 5 specific objectives. First, to summarize the general research area and explain the contribution of the selected paper. The second, to examine the conceptual BOT architecture and the methodology the authors adapted. Third, and the most importantly, to the paper it against and what developments have happened since it was written. Fourth, to analyze the legal, social, ethical, and professional issues raised by the integrating blockchain with cloud-hosted IoT data. And the fifth, to draw a conclusion on the maturity limitation and the future direction of BCOT. In slide 5 actually, the research area sits at the intersection of three established fields: distributed ledger technology, the IoT and the cloud computing. Interest in combining blockchain with IoT predates at this paper is surveyed significantly. In 2007, Dory and the co-team demonstrated the lightweight blockchain for the smart home, removing proof of work to suit constrained devices. Novo in 2018 proposed a scalable blockchain-based access management architecture for IoT. Reina and the team in 2018 systematically identified scalable storage throughout as the central obstacles challenges that remains resolved today. Ali and the team at Atlum and Wheels extended this analysis in 2019. Yang and 2019 review 2000 review the blockchain integrates with edge computing. Against the backdrop, this paper observed the gap while BOT and blockchain cloud integrations as each surveyed separately. No comprehensive review addressed the three-way coverage, blockchain, cloud and IoT together, which is the gap there. BCOT survey fields. In slide 6, first they provided state of the art synthesis explaining the complementary relationship blockchain offers decentralization and security, while cloud offers scalability and fault tolerance. Second, they propose layered conceptual BOT architecture, which I will describe in the next slide. Third, they deliver as an in-depth taxonomy-based survey of BOCT application across smart healthcare, smart city, smart transformation and smart industry, covering commercial platforms including Ethereum, Hyperledger and blockchain as service offers from Amazon, IBM, Microsoft and Azure and Oracle. Fourth, the most useful researchers, they identify 5 challenges: standardization, security, vulnerability and privacy, leakages, intelligence and resource management, outlines figure directions including lightweight consensus mechanism, machine learning, big data and 5G. Let me, in slide 7, let me describe 3-layer BOCOT architecture proposed by the paper. At the bottom of this IoT layer, this is where physical devices, sensors, actuators, wearable, harvest data and whole blockchain across lightweight gateways relay a transaction to upper layers. In the middle, in the middle is the cloud-based blockchain middleware layer, which is heart of the BCOT. This layer delivers blockchain as service and provide shared ledger functionality, consensus mechanism, smart controls and cryptographic services. Alongside blockchain, this layer includes cloud of services in the B, SAS, PaaS and LaaS modules and decentralized storage solutions such as IPFS and SWARM. Commercial platforms occupying this layer including Ethereum, Hyperledger, Fabric and the managed blockchain as service. And at the top of the adaptation layer, the industry domains and consume 3 services: smart healthcare, smart city and smart transformation. Data and transaction flow forward through the layer. First, trust, decentralization, security flow background. And in slide 8 actually the paper narrative state of the art literature survey rather than an experimental study. This approach is approximately given aim to mapping emerging fragmented field. You cannot run at experiment on the paradigm that does not yet fully exist. The authors draw an academic article, review reports, commercial documentation and news sources, and organize evidence using comprehensive tables and application application. They include quantitative figure for context, notably throughout the comparison. Bitcoin processes roughly 4 transactions per second, Ethereum about 20 against Visa. However, the methodology has clear limitations. The absence of the documented protocols such as defined search and string and the criteria limits reproducibility compared to reviews like the architecture proposed also remains conceptual. It is not validated through a prototype or performance benchmark, which weaknesses its contribution. In slide 9, my critical analysis review both significant strengths and important and limitations. On the strength side, the survey comprehensive. It is among the first threat blockchain, cloud, and IoT single integrated stack. The company-friendly framing and on the and the inclusion commercial blockchain as services perform give work relevances beyond academics. On the limitation side, 4 issues stand out. And in slide 7, legal issues. Improved trust transparency in and social issues, there are some legal and social issues as well. In slide 11, we are talking about the moving to social and ethical issues. Socially, BCOT promises improved trust and transparency and greater citizen control over data in domain like smart healthcare and smart cities. However, IoT sensing incentive survey concerns some sensors that provide vulnerable services can also enable mass monitoring of individuals. There is also privacy paradox. And also ethically developers must weigh the benefit of immutability of details against the very real harm of permanently record survival sensitive data. Throughout stakeholder analysis spanning parties, citizens, services providers, and regular and application establish ethical tests and essential before deployment, particular safety critical healthcare system. In slide 12, professional issues, engineers. We are talking about professional issues. Engineers build BOCT systems are bound by code of conduct such as BCS code of conduct members, and which require due regard of public interest, professional, and those kind of things. Smart contract vulnerabilities, including attacks, mishandled exception, and the 51% attack illustrate why bad testing security risk can be other things. And discussion of findings as sliding. Since my discussions of findings confirm that BCOT is genuinely promising paradigm, and that the central argument of mutual reinforcement between blockchain and the cloud of remains sound. The strongest finding is that the challenge identified by this paper, established in 2020, scalability, security, and privacy, continue to dominate subsequent literature, including the survey correctly diagnosed the field priorities. However, 3 consequence developments since 2020 must temper any technical optimism. First, Ethereum 2022 consists of proof of stake reduce energy consumption by an estimated 99%, fundamentally changing sustainability picture. Second, federated learning and blockchain secured AI have emerged as major approaches to addressing the intelligence gap and the paper identified. Third and most important, governance realized non-dominated technical feasibility alone is insufficient, and immutability conflict remains a barrier to lawful deployment. A limitation of this report is reliance on a single primary source supplemented by secondary literature. Future research should promise standardized privacy by design BCOT framework that are demonstrated compliant with data protection law. Let me conclude the report as critical review and contextualize the BCOT paradigm with the wider research landscape. The integration of blockchain and cloud of things offers a compelling route to decentralized scalability and secure IoT services and surveyed architecture applications, and challenge remains vulnerable reference and practitioners. Yet the analysis shows that technical feasibility alone is insufficient, and immutability and erasure conflict and concerns and professional security obligations mean that LSEP considerations are decisive for responsible adoption. BCOT will mature not merely through faster consensus algorithm and smart analysis, but through architecture design from the outset lawful, ethical, and trustworthy. Further research must prioritize standard privacy by BCOT framework that demonstrate compliant GDPR and evaluate data protection law. Thank you for listening. I'm happy to end. Thank you very much.